In this demonstration, we will enhance SSH security by disabling direct root login, which is a critical step in preventing brute force attacks. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's create a backup of SSH configuration file, just in case we need to restore the original settings later. In the terminal, type this command: cp/etc/ssh/etc/etc/sshd_config/etc/sshd_config.bak. Here, in this command, cp is the command to copy files. /etc/ssh/sshd_config is the original SSH configuration file. /etc/ssh/sshd_config.bak is the backup file we're creating in the same directory. Now press Enter. This command makes a duplicate of the current SSH config file and saves it as sshd_config.bak, keeping your original settings safe. Next, we need to open the SSH configuration file using the nano text editor. In the terminal, type the following command: nano/etc/ssh/sshd_config. Then, press Enter. This opens the file in the nano text editor. Now use the down arrow key on your keyboard to scroll through the file. Look for the line that says #permit root login prohibit-password. Here's what we'll do. Uncomment the line by removing the hash at the beginning and change prohibit-password to no. So the updated line should look like this: permit root login no. This setting disables all direct root logins, adding an extra layer of security. Once you've made the change, press Ctrl+X to exit. Then press Y to confirm the save and Enter to write the changes. Your updated SSH configuration file is now saved. Now let's check the SSH configuration file for any syntax errors before restarting the service. In the terminal, type the following command: sshd-t. Here, sshd is the SSH daemon. -t tells it to test the configuration file for syntax errors. Press Enter. If there's no output, that means the syntax is correct. Next, restart the SSH service to apply the changes. Type systemctl restart sshd. Then press Enter. This command restarts the SSH daemon with the updated settings. Let's check the status to make sure it's running properly. Type systemctl status sshd and press Enter. In the output, you should see that the service is active and running, which means your changes were successful. Clear the terminal screen for a fresh view. Now let's create a new user. In the terminal, type user add Mike. Here, Mike is the username for the new user. Then, press Enter. The user account for Mike is now created. Next, we'll set a password for this user. Type passwd Mike. Then press Enter. In the output, you'll see a message like changing password for user Mike. Now type a new password and retype it when prompted to confirm. Once the password is successfully set, you'll see a confirmation like all authentication tokens updated successfully. Clear the terminal screen again. Now let's switch to the Mike user account. In the terminal, type the following command: su-mike. Here, in this command, su stands for substitute user, and -mike tells the system to switch to the Mike user and load their environment. Press Enter. In the output, you can see we are now logged in as Mike. Clear the terminal screen. Now let's test if SSH access for the root user is truly disabled, just as we configured. In the terminal, type the following command: ssh root add John. Here, in this command, SSH starts the SSH connection, and root add John means you're trying to connect to the system John using the root account. Press Enter. The system may respond with a message like, "Are you sure you want to continue connecting?" Type yes and press Enter. You'll see a message like, "Permanently added John to the list of known hosts. Next, when prompted, enter the root password. You'll get an error message. Permission denied. Please try again. That's because we've explicitly disabled root login in the SSH configuration file. No matter how many times you try, even with the correct password, you'll see the same result. This confirms that SSH root login has been successfully disabled. And that concludes our demonstration on enhancing SSH security by disabling direct root login. In this demonstration, we'll set up passwordless SSH access using a secure key pair. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's generate an SSH key pair. In the terminal, type the following command: ssh-keygen-t small RSA-b 4096. Here, in this command, ssh-keygen is the command used to generate the key pair. -t small RSA. Specify the type of key that in this case is RSA. -b 4096 sets the key strength to 4096 bits for better security. Now press enter. You'll see a message like generating public/private RSA key pair. When prompted with enter file in which to save the key, just press enter to accept the default location. Next, you'll be asked to enter a passphrase. You can choose to set one for added security or leave it empty and press enter. Then re-enter the passphrase when prompted and press enter. Once done, the system will generate a public and private RSA key pair, encrypted using SHA-256. Let's clear the terminal screen for a fresh view. Now let's copy the public key to the remote system to enable passwordless SSH access. In the terminal, type the following command: ssh-copy-id mike@john. Here, in this command, ssh-copy-id is the command that installs your public key on the remote system. Mike@john refers to the user and the host you're connecting to, which in this case is the user mic on the system named John. Now press enter. If ssh-copy-id is already installed, it will proceed. If not, the system may prompt you to install it. Just follow the instructions. When prompted, enter Mike's password. Once the key is copied, you'll see a confirmation message showing the number of keys added to John, which in this case is 1. Clear the terminal screen again. Now let's update the SSH configuration to fully enable passwordless authentication. We'll do this by editing the SSH configuration file using the nano text editor. In the terminal, type the following command: nano/etc/ssh/sshd_config. Then press enter. This will open the file in the nano editor. Now use the down arrow key to scroll through the file and look for the line that says #password authentication yes. Here's what we'll do. Uncomment the line by removing the hash at the beginning. Then change yes to no. So the updated line should look like this: password authentication no. This setting disables password-based logins, allowing only key-based authentication. Once you've made the change, press Ctrl-X to exit. Then press Y to confirm the save and enter to write the changes. Your updated SSH configuration file is now saved. Now let's log in as the Mike user, using the key-based authentication we just set up. In the terminal, type the following command: ssh mike@john. Here in this command, SSH starts the secure connection, and Mike@john means you're connecting to the system named John as the user mic. Press enter. This time, you'll notice something different. You're logged in without entering a password. That's because the SSH key pair is now handling the authentication securely and automatically. And that concludes our demonstration on setting up passwordless SSH access using a secure key pair. In this demonstration, we'll change the default SSH listening port, port 22, to help reduce exposure to automated attacks. To begin, click on the Activities tab in the top left corner of your screen. Then, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, we need to modify the SSH configuration file to change the default SSH listening port. To do this, open the SSH configuration file using the nano text editor. In the terminal, type nano/etc/ssh/sshd_config. Then press enter. This opens the file in the nano editor. Now look for the line that says #port 22. Use the down arrow key on your keyboard to scroll through the file. Here's what we'll do. Uncomment the line by removing the hash at the beginning, and then replace 22 with 2222 or any other custom port number you'd like to use. So the updated line should look like this. Port 2222. In this case, 2222 is the custom port we'll use for SSH. Once you've made the change, press Ctrl+X to exit, then Y to confirm the save, and Enter to write the changes. Your updated SSH configuration file is now saved. Now let's add port 2222 to the firewall so the system can accept SSH connections on the new port. In the terminal, type the following command: firewall-cmd-permanent-add-port equals 2222/TCP. Here, in this command, firewall-cmd is the command line tool for managing the firewall. --permanent makes the change persistent across reboots. --add-port equals 2222/TCP adds TCP port 2222 to the list of allowed ports. Now press enter. In the output, you'll see a message that says, "Success." This confirms that port 2222 has been successfully added to the firewall. Now let's reload the firewall to apply the changes. In the terminal, type firewall-cmd-reload. Then press enter. This command reloads the firewall configuration, and you should see the output. Success. Next, let's verify the SSH configuration file for any syntax errors before restarting the service. Type the following command: sshd-t. Here, -t option tells the system to test the configuration without applying it. Press enter. If there's no output, that means the configuration syntax is correct. Clear the terminal screen for a fresh view. Now we need to restart the SSH service so it can listen on the new custom port. In the terminal, type systemctl restart sshd. Then press enter. You may see an error message like job for sshd.service failed because the control process exited with error code. This happens because SELinux is preventing the SSH service from using the new port. To allow SELinux to manage the custom port, we need to add it manually. Type the following command: semanage port-a-t ssh_port_t-p TCP 2222. In this command, semanage port is used to manage port contexts in SELinux. -a adds a new rule. -t ssh_port_t sets the type as an SSH port. And -p TCP 2222 specifies the protocol and the custom port number. Press enter. This command adds port 2222 to the list of SELinux approved SSH ports. To confirm, type semanage port-l, insert a pipe operator followed by grep SSH. Here, -l lists all SELinux port rules. The pipe sends the output to grep, which filters and displays only lines containing SSH. Press enter. In the output, you should see that SSH_port_t is now associated with port 2222, confirming the configuration was successful. Now let's restart the SSH service again. In the terminal, type systemctl restart sshd. Then press enter. This time, the service should restart successfully. To verify that it's running, type systemctl status sshd. Then press Enter. In the output, you should see that the SSH service is active and running. Clear the terminal screen. Now let's test the SSH login using the new custom port. In the terminal, type the following command: SSH-p 2222 Micah John. Here, -p 2222 tells SSH to connect using port 2222 instead of the default port 22. Micah John specifies the user and the system you're connecting to. Now, press Enter. In the output, you'll see that we've successfully logged in to the system named John as the user mic, using the custom SSH port. Clear the terminal screen. Then, to exit from the session as Mike, type exit and press Enter. And that concludes our demonstration on changing the default SSH listening port, port 22, to help reduce exposure to automated attacks. In this demonstration, we will reduce the risk of brute force attacks by configuring a login threshold for SSH in Red Hat Enterprise Linux. To begin, click on the Activities tab in the top left corner of your screen. Then, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, we need to update the SSHD configuration file located in /etc/SSH folder. To do this, open the SSH configuration file using the nano text editor. In the terminal, type nano/etc/SSH/SSHD_config. Then press Enter. This will open the file in the nano editor. Now use the down arrow key on your keyboard to scroll through the file. Look for the line under the Authentication section that says #maxauth_tries6. Make the following changes. Change the number 6 to 3, and remove the hash symbol at the beginning to uncomment the line. The updated line should now read maxauth_tries3. This setting limits the number of failed login attempts before the SSH connection is dropped. Next, locate the line #maxsessions10. Here, change 10 to 2, and remove the hash symbol to uncomment the line, so it becomes maxsessions2. This restricts the number of simultaneous open sessions over SSH. Now scroll up and find the line #login grace time 2M. Here, remove the hash at the beginning and change 2 minutes to 30 minutes. So the updated line should be login grace time 30M. This defines how long the server waits for a user to successfully log in before disconnecting. Once all changes are made, press Ctrl+X to exit. Then press Y to confirm and press Enter to save the file. Your updated SSH configuration is now saved. Now let's check the SSH configuration file for any syntax errors before restarting the service. In the terminal, type the following command: SSHD-t. Here, SSHD is the SSH daemon, and -t tells it to test the configuration file for syntax errors. Press Enter. If there's no output, that means the configuration is valid. Next, restart the SSH service to apply the changes. Type systemctl restart SSHD, then press Enter. This command restarts the SSH daemon with the updated settings. Now let's test SSH access with limited authentication attempts. In the terminal, type SSH Mike add John. Here, in this command, SSH starts the SSH connection, and Mike add John is the username and hostname you're connecting to. Press Enter. When prompted, enter a wrong password for Mike add John, then press Enter. In the output, you'll see permission denied, please try again. This indicates attempt 1 failed. Now, enter the wrong password again. After pressing Enter, you'll again see permission denied, please try again. This is attempt 2. Finally, enter the wrong password a third time and press Enter. This time, you'll be disconnected from the server automatically. This confirms that our new setting, maxauth_tries3, is successfully limiting SSH login attempts to 3 tries only and dropping the connection after 3 failed attempts. And that concludes our demonstration on reducing the risk of brute force attacks by configuring a login threshold for SSH in Red Hat Enterprise Linux. In this demonstration, we will troubleshoot the SSH service using 3 key methods: syntax validation, logs, and connection testing to help prevent misconfigurations and minimize downtime. To begin, click on the Activities tab in the top left corner of your screen. Then, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's check the SSH configuration file for any syntax errors. In the terminal, type the following command: sshd-t. Here, sshd is the SSH daemon. -t tells it to test the configuration file for syntax errors. Press Enter. If there's no output, that means the configuration is valid. Now, let's intentionally introduce an error to see how syntax validation helps. Open the SSH configuration file using the nano text editor. In the terminal, type nano/etc/ssh/sshd_config. Then press Enter. This opens the SSH configuration file in the nano editor. Use the down arrow key to scroll through the file. Locate the line that says port 2222. Change the word port to port T. That's PORT-T. This introduces a syntax error into the configuration file. Once done, press Ctrl-X to exit. Then press Y to confirm and Enter to save the file. You've now saved the updated but intentionally broken SSH configuration. Now let's recheck the SSH configuration file for errors. In the terminal, type sshd-t. Press Enter. In the output, you should see a message like /etc/ssh/sshd_config, line 21, bad configuration option, port T. This tells you exactly where the syntax breaks. In this case, a misspelled keyword on line 21. Now, let's fix the error. Open the SSH configuration file again using the nano text editor. Type nano/etc/ssh/sshd_config. Then press Enter. Scroll down and correct the spelling of PORT-T to PORT. Once done, press Ctrl-X to exit. Then press Y to confirm and Enter to save the file. Let's revalidate the configuration. In the terminal, type sshd-t. Then press Enter. This time, there should be no output, meaning the configuration is valid again. Clear the terminal screen for a fresh view. Now let's check the SSH connection using verbose mode. In the terminal, type ssh-v mic@John. Here, -v enables verbose output, which provides detailed information about the SSH connection process. mic@John is the username and hostname you're connecting to. Then press Enter. You'll notice in the output, SSH is reading all configuration files. It is trying to connect to port 22, but the connection is refused. This likely happened because we haven't restarted the SSH service after making changes. Let's fix that. First, clear the terminal for a clean screen. Now restart the SSH service to apply the changes. Type systemctl restart SSHD. Then press Enter. This restarts the SSH daemon and loads the new configuration. Let's test the SSH connection again using verbose mode. ssh-v mic@John. Press Enter. This time, you'll see the system process all steps and finally login was successful to the user John. If any issue occurs, the verbose output will highlight where the problem is, making it easier to troubleshoot. To exit from the mic user session, type exit, then press Enter. Clear the terminal screen again. To view more detailed SSH debug output, you can use the following command: ssh-vvv. In this command, the 3-v option enables maximum verbosity. This shows detailed debugging information at each stage of the SSH connection process. It's especially useful when diagnosing authentication, network, or configuration issues. Now let's check the SSH logs. In the terminal, type journalctl-xeu sshd. Here, journalctl displays system logs. -x shows extra context for log messages. -e jumps to the end of the log. And -u filters the logs to show entries related only to the SSHD service. Then press Enter. In the output, you'll see detailed logs related to SSHD, such as confirmation that it is listening on port 22, user mic logging in, the UID assigned to mic, and various other authentication and session-related messages. To exit the log view, simply press Q. And that concludes our demonstration on troubleshooting the SSH service using syntax validation, logs, and connection testing to help prevent misconfigurations and minimize downtime. In this demonstration, we will tackle SELinux context issues for SSH keys that can silently block SSH authentication, even when the correct keys are used. To begin, click on the Activities tab in the top left corner of your screen. Then, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's check the SELinux context of the SSH directory. In the terminal, type ls-z_/.ssh. Here, in this command, ls lists files. -Z shows the SELinux security context. ~/.ssh points to the hidden SSH directory in the current user's home. Then press Enter. In the output, you may see something like ~r://object_r/ssh_home_t:/s0. This indicates the wrong SELinux context. Because of this, SELinux would not allow SSH to use the keys, even if they're correct. To restore the correct context, type the following command: restore con -R v ~/.ssh. Here, in this command, restore con is used to fix SELinux context. -R applies it recursively. -v enables verbose output. ~/.ssh is the target directory. Press Enter. Now recheck the context to confirm the fix. Type ls-z ~/.ssh. Press Enter. The context is still not fixed, so we'll try another method. Let's use chcon to manually set the correct SELinux context. Type the following command: chcon -t ssh_home_t ~/.ssh. Here, in this command, chcon changes the SELinux context of a file or directory. -t ssh_home_t sets the correct type for SSH directories. Press Enter. Let's test the SSH login again. Type SSH John. Press Enter. Now SSH keys are valid, and you should be successfully logged into the John system. To exit the John session, type exit. Press Enter. And that concludes our demonstration on tackling SELinux context issues for SSH keys that can silently block SSH authentication.